Good afternoon, everyone. Welcome to the sixth Tech Espresso on behalf of XR Valley. Happy to have you all here. Just if you haven't been here before, this webinar is a monthly moment of gathering for the XR community in Belgium, specifically for people that are involved with building XR tech. And in this webinar, we are diving into new technological advancements in the XR space, and not only the new tech, but also the opportunities and challenges that come along with it, of course. And most of all, this is a place for you to discover and connect with people that are building XR in all shapes and sizes. Today, we are joined by Anne Hermans, who is product manager of SenseGlove. SenseGlove develops haptic feedback gloves, which allow users to interact with VR and XR in a very intuitive way instead of with like controllers. And this is a super great tool, for example, for workforce training or research. In 2024, they released their latest gloves, and Anne is here to tell you all about them. As usual, if you have questions during the presentation, you are free to drop them in the chat that you see next to the stream here, and we will address these after the presentation. So for now, sit back and relax, and I'm inviting Anna to the stage. Please enjoy the show.
Okay, hello everybody. Thank you for the introduction and thanks a lot for having me today. So I'll be talking about haptics and telerobotics. And I know that this is an XR platform, and when we think about XR, virtual and augmented reality, it's usually first visuals and then maybe audio, so the senses of sight and hearing that come to mind. The sense of touch, so haptic feedback, may already feel like a step removed from your usual core XR subject matter. And then I'm taking another step away from that, involving robotics. So I'm going to do my best and try to make it all come together for you. And if I don't succeed, let me know in the chat, and there'll be a lot of time for Q&A at the end. So let me start by a general introduction of SenseGlove. Founded in 2017 by Johannes and Gijs, I joined the team in 2019 as I think the 8th team member. And as of now, we have about 35 FTEs. So we have seen some considerable growth over the past few years. We've secured 5.5 million euros in seed and Series A funding, which we've used to put 3 products in the market so far, which are by now on the hands of over 500 unique customers worldwide. And this team of around 35 people is really spread out over a wide range of expertises. So we make wearable hand haptic devices, so the hardware, the product, but we don't only design and develop them, we also have our own production team that produces and assembles the gloves in-house. We have a software team to make sure that clients can successfully integrate our devices into their simulations, for example, by providing a Unity and Unreal SDK. And of course, we have a sales and marketing team to ensure that we have interesting opportunities such as today to talk about what we do. And what we do is all about feeling in XR. And specifically, since our hands are what we use to interact with the world and to manipulate the world, hand haptics. Hand haptics starts with hand tracking, because to apply suitable feedback to the hand, appropriate to the situation, appropriate to what is happening, you need to know where the hand is, what object it's interacting with, what is it doing. And then you can build several haptic technologies on top of that. Wait, I see I am not sharing my screen. Okay. Sorry for that. Is it showing now? I think so, right? Yes, okay, great. So where was I? Yeah, the hand tracking. And so we built the other haptic technologies on top of that. First of all, fiber tactile feedback, so vibrations, which can allow you to feel, for example, buttons, switches, and rough textures as you move your fingers over virtual surfaces. Then there is force feedback, which allows you to feel the size and the stiffness of an object, whether it's hard or soft. Then there's contact feedback, which allows you to feel the shape of an object, so actually feel it pressing into your hand. And finally, temperature feedback is something hot or cold or somewhere in between. And except for temperature feedback, we use all of these haptic technologies in our projects. And the different type of products that we make can be categorized into these three categories. First of all, the force feedback haptic gloves to simulate all sorts of interactions in virtual reality environments. Then there is custom haptic props, where we make a very specific object for one very specific use case, such as you can see in the image. And finally, force feedback exoskeletons. So there's a variety on a glove where it's actually an exoskeleton on top of your hand. And these are used for robotic applications, which I will be talking about more today. These are the products that we've released so far. So the first is the exoskeleton, our DK1, which we do not longer produce. The same goes for the Nova, which was developed specifically for training simulations in VR. And the Nova 2 is the one that we are currently still selling, also designed for training in VR. And the thing that binds all of our together is that we want them to be a bridge between reality and the digital. So for example, if you know how to operate a drill in real life, you can also use a virtual drill because it works the same. You don't have to find out which switches on a controller turn it on, or what gesture to make with your fingers. You just use your index finger to press the virtual switch as you would in reality. And the other way around, if you learn how to use, for example, a fire extinguisher in VR, in a VR training simulation, you actually learn how to activate the fire extinguisher and not what button to push on a controller in case of a fire. So it can all be boiled down to this vision. Let the sense of touch bring interactive digital environments to life. That is a vision for our product portfolio. And the examples that I just mentioned come down to a person learning or practicing something in XR, such as how to use a wrench. But this digital environment that we want to bring to life can also pertain to a robot, where a human operator uses a robot as an interface to interact with the world. And then it's these digital interactions, so the human interacting with the world through a robot, that we want to bring to life using the sense of touch. And this is where we come to Telerobotics. So the operation of a robot at a distance, and this distance can be very small, such as in this image, standing right next to the robot, or the robot can be anywhere else in the world, so very close or far away, doesn't matter. Of course, not all telerobots can manipulate the physical world. Some are pure about telepresence, so they can only communicate, for example, a screen that can move around. But we're interested in those robots that can manipulate their surroundings, so that have some form of grippers, and more specifically, robots that have dexterous humanoid hands, so hands with 4 or 5 fingers that can manipulate objects, sort of like humans can. Because these 4 or 5 fingered dexterous robotic hands require a human hand to operate them, because a joystick or a computer mouse or keys, it's just not going to cut it when you have 5 fingers to operate. So that's where it's interesting for us to develop a product. But let's first talk about teleoperation in general a little bit more. Why would you even want to use teleoperation? So a robot that is operated by a human and that does something. Well, there is a variety of reasons when that could be interesting. For example, in dangerous environments where you just don't want humans to go, and you want to send a robot out there, for example, for bomb disposal, inside nuclear reactors, or in contagious environments. Another example is remote environments where it's just very difficult for a human to go, like the deep sea or outer space or deep in mines. It also becomes interesting to let a robot do tasks when the tasks are very monotonous or repetitive, such as in manufacturing or maintenance settings. And there, of course, you would like the robot to do that autonomously. And I will get back to that later on. And the same goes in case of labor shortage, where you just want robots to do a job instead of a human. This can be interesting in also manufacturing or healthcare. In some cases, robots can be more efficient than humans. And in other cases, you just simply want to avoid travel. This can also increase efficiency. For example, if you have an expert with a person with a very rare expertise that you want to deploy in different settings around the world, and you can do that through a robot. Or where, as a consumer, you would like to go somewhere and experience something, but you don't want to physically go there. It would be interesting if you could do that through a robotic avatar. And there are different ways in which you can apply a robot in these use cases. So the simplest one is just, or the most straightforward one is one-on-one control. So there is a human in place A, and there's a robot in another location. The human is wearing one of our devices, and the robot's hands just copy exactly what the human is doing at that moment. So that allows this human operator to control the robot that is in a different place, one-on-one in real time. So that's the case of a robotic avatar. You could also imagine a case where you have an operator controlling a robotic fleet. So there is a fleet of robots operating autonomously, doing certain tasks, for example, in a manufacturing facility. And once in a while, the robot encounters something that they cannot solve on their own, or there is an error, and then a human might have to intervene. And so this operator can switch from robot to robot whenever it's needed. The first case, which you can see on the left in this slide, is imitation learning. And this is actually the training of a robot to do something autonomously. And you can do this by recording hand data of humans doing something and then feeding that into a data set for imitation learning of a robot. But it's actually better to do that through teleoperation. So you have the human operator controlling a robot directly to do a certain task, and then you record how the robot does that through the teleoperation, and you can use that to teach the robot how to later do that task autonomously. SenseGlove already has quite a lot of experience with teleoperation in these different settings and applications. The Nimbro team from the University of Bonn, for example, won the ANA FDR-X prize using RDK1, and several other finalists also used RDK1 in that competition. So that's how we knew, well, this is an interesting field for us to continue in. Here is another example of Gijs operating a robot in a project that we did together with TNO. Then the next question is, in all these telepresence and teleoperation use cases, why would you include haptics? Well, the three most important reasons are, first, you cannot see everything. Usually these robots will have cameras in a place where sort of its head would be. And as you do things as a human, for example, if you put your key in a door lock, you really use the sense of touch for that, because your hand will at some point obstruct your vision. It will, and you will feel when the key goes into the lock before you have to turn it. And the same goes for using a screwdriver or all sorts of other tools. You just cannot always fully rely on vision. So the sense of touch can be very important to give you information that you need to complete a task, and so also to make a robot complete that task. Secondly, in dexterous manipulation. So if you have a robot hand with 4 or 5 fingers doing complicated tasks, imagine you have to do a dexterous task like switching two balls in your hand without feeling anything. That's just very difficult without a sense of touch. And finally, to allow the operator to exert the appropriate amount of force. Imagine you're operating a robot that has to handle different types of fruits or vegetables. And some will be very fragile and like tomatoes, and you want to hold them softly so not to break them. If you have no feedback as an operator on how much force you are exerting, you also cannot exert the appropriate amount of force, not tell the robot how hard to squeeze. So that's another important reason why we want haptics. And in imitation learning, so where you want to train a robot, so make a data set to teach a robot how to do something, it's also very valuable that the human can feel how much force they are applying by giving that feedback to them. And then the other way around, also record how hard the human is squeezing, so that we have also this force data in the imitation learning data set. Now I'd like to show you a little bit about Project Rembrandt, which is the device that we are currently developing, co-funded by the European Media and Immersion Lab, EMIL. So where our previous products, the Nova and the Nova 2, were aimed at training humans, this one will be really developed for training robots. So we say the ultimate tool for the dexterous teleoperation of humanoid robots based on the perception of force. And we are building upon our DK1, which I showed you previously. We discontinued this already a few years ago. It was an exoskeleton, and it had force feedback, passive force feedback on all 5 fingers. So the passive force feedback means that if you would grab a virtual object, or if a robot would grab an object, then the human, the user, feels the resistance of that object in their hands. So as I'm holding this glass, if this were not a real glass, I would still feel the resistance of the glass on my fingertips. And the passive aspect there means that it only stops my fingers. It cannot actively move my fingers. We have vibration feedbacks on all 5 fingers and on the back of the hand. And we could track the hand and all fingers in a very robust and accurate way, at least the endpoint of the fingertips. But as I said, we are building upon this device. So we are going in a slightly different direction. First of all, with the exoskeleton, which we have redesigned. Here you see the exoskeleton for just 1 finger, where the DK1 was just connected on the back of your hand and then on the fingertip. This one will be connected to all finger phalanges. Which increases the tracking of the fingers. So we have more information on finger motion and position. It also gives a better and more stable sense of the force you are feeling, and it allows for more comfortable finger movement. And this is a concept sketch of what we are making in Project Rembrandt. So except for the redesign of the finger exoskeleton, most important new development is that the force feedback will now be active. So I just described to you the passive force feedback, where you can just feel the resistance of an object on your fingertips. Now we can also slightly pull the fingers in this direction. What is the benefit of that? Well, if you now squeeze an elastic object, so you compress it a little bit. I don't have an elastic object here right now to show you, so you have to imagine it in my hand. If I compress this object a little bit, then there will be the elastic force that will pull your fingers out again in reality. And with this active force feedback, we can also simulate this on the fingers. So if you have a robot hand that can also sense those forces, we can display those forces on the operator's hand. So they will have more information on what sort of object the robot is handling and how that feels. And so also they will be better equipped to apply the appropriate amount of force in their operating of the robot. So that counts for elastic objects or for springs that you decompress, but also if the hand is pushed into a table, for example, and your fingers are pushed upwards like that, we can also simulate that. So I've been talking a lot about forces and active and passive force feedback. And what's also new in the Rembrandt compared to our previous product is that we have integrated force sensing, which, as I explained, is vital in training robots to properly handle different situations and objects. So we can track not only the position of the fingertip, but also of the entire finger quite accurately in our new design. Everything at a high sample rate. What's also interesting is that it is being designed not only for standalone use. So for example, if you would mount a VR tracker on top, but it will also be mountable to a haptic arm. And there you show you the video again. You can see here the DK1 was also mounted to a robot arm. And then the arm does the positional tracking of the hand in space, and it can also apply grounded feedback. So then the operator can also feel the weight of an object that the robot is picking up, or if it is bumping into a wall, for example, you would be able to feel that as well. And where in the DK1 we had fiber tactile feedback on all the fingers and on the back of the hand, we will now have it also on all the fingertips, but on the palm of the hand, which makes more sense because that is where most interactions happen, and not on the back of the hand. So yeah, this is what we are currently working on at SenseGlove. And yeah, as was on the very first slide, our slogan is training the workforce of the future. And with the Nova and the Nova 2, that was aimed at training humans, so allowing them to practice something in virtual reality environments. And with this device, the Rembrandt, we want to be able to train robots as well, so that they could finally do things autonomously and be part of the workforce of the future. That's as far as I had prepared my talk. So I'm curious to hear your reactions and questions.
Ew. Any questions in the chat? I don't see them yet. I do have a few, if I may.
Of course.
Cool. Thank you so much for the presentation. It was really enlightening. I do have to say I have like a slight irrational fear still that when you would wear this, that your fingers will be pulled in the wrong direction. But as you explained, this is not possible at all. This is irrational, but still.
Well, a lot of people have that fear also with our current products, and with the current products, it's not possible at all, indeed, because yeah, it's only the resistance that we can apply. And with this one, yeah, we can apply a pull on the fingers, so the fear is a little bit more grounded, but still we will make sure that there is a limit to how far you can pull, so that your fingers cannot be hyper extended.
Great.
For safety. Yeah.
So then all fears are gone.
Good.
Awesome. Let's see. Davey is asking, has there been any research on the importance of latency when teleoperating robots? Is there a maximum to make it feel immediate?
Yeah, latency is very important in teleoperation, and specifically when you want to provide good haptics. Because yeah, simply if the latency becomes too high, you will feel something when you're already steps past that, and it becomes impossible to control a robot. Which is why we are aiming for that 1 kilohertz sampling rate.
Cool.
Which should be fast enough for good teleoperation.
To get, yeah, feel as much natural as possible also, I guess.
Yeah.
Nice. Let's see, maybe this is related to that, but I'll let you have the word on that. I was wondering how do you measure user immersion in terms of using this product? Is there any research that you're doing on that, or what kind of metrics do you have at hand to sort of monitor that, if any?
How do you? Yeah, we do. We have done tests with in previous simulations on, for example, sense of presence. And immersion is it's a difficult concept, right? Because there are so many different things that factor in on that.
Exactly. Yeah.
And yeah, usually we are very practical. So we do a lot of user tests, internal, whatever we make within the team, but also with customers and on fairs, and we look at how people react and what their feedback is. So that's not the scientific method, but a very practical method.
Well, yeah, that's the challenge, right? How do you measure an experience really? And I mean, that is one way to sort of measure, you have the interactions and the use cases. And I guess also accuracy of, the task at hand, what's
Yeah.
being done. But yeah, it's interesting. And yeah, I think it's related to sort of XR embodiment, maybe even, which has even more facets than only that touch and sense. It also goes into, you know, the amount of agency someone has over what's being done in the virtual world, so to say, and how they manage it. So yeah, there was just a personal interested question.
Yeah, how intuitive it is to do something, that's very important to us.
Yeah.
Also more important than hyperrealism, for example. That's not necessarily what we strive for, hyperrealism, but we want to give just enough cues that that the interactions, that the simulations are intuitive, and indeed that you have a nice sense of agency, which allows you, we think, to better learn, for example.
Exactly. Yeah, and still a lot to go there, but I think you're sort of paving the way, in a way there. So that's awesome.
Yeah, and from personal experience, of course,
Yeah.
I've been since we work with haptics, so I've been a lot in VR with our own haptic products, and then once in a while, when I'm in VR and I've just used hand tracking, for example, and I don't get any feedback, that really annoys me. So I do think that there is there is a lot there, and to give that sense of embodiment and immersion. If you get feedback on what you do, and when you're not a ghost, it just passes through everything.
Absolutely. Yeah, and definitely because you're involved in creating this, what's already possible out there with the technology, and then when it's not always implemented, I can assume that's sort of not a mismatch, but what's possible, and if it's not there, that's kind of a step back. That's what it feels like, I guess.
Yeah, definitely.
Yeah. Maybe I can relate to the question that's being asked by Simon now, also making it, how do you position yourself as a relatively small hardware company? How do you position yourself in the market? Maybe towards other bigger players, but maybe also additionally, how do you make sure that as many people get access to your products as well? Kind of twofold question, maybe.
Yeah. So it stays a relatively niche market. So no, there are no really big competitors with a similar technology. Of course, there are other smaller companies doing the same, but not a lot, and also none specifically the way that we do it. And your question, and we are also, we want to be an accessible, we want our technology to be accessible.
Yeah.
So the Nova 2, for example, we sell for 6,000 euros, which is a lot of money, but compared to competitors out there, it is quite cheap for the for that type of technology. So yeah, we do try to be as scalable as possible in that way.
Great. Can you share a bit about I think you mentioned it briefly, but the range of clients that you have now, if you're willing to share?
Yeah, it's a lot of, for example, in automotive production business, but also aviation, healthcare, defense, all sorts of, actually anywhere where it's important to train employees in things that are where it's hard or expensive or very time consuming to train only physically. Like a car manufacturing line, if you want to train personnel to put something together, you have to stop the entire manufacturing line, and that is very costly. So even if you can just prepare people in VR in a safe environment where nothing happens if you make a mistake, that can be very advantageous. So in sectors like that is where we find most of our customers.
Yeah, probably will be evolving also over time as more and more industries see the benefit of applying this. So maybe a last question coming from my side, and then we can see if there's anything more. But what is sort of the broad future that you see for SenseGlove and maybe haptic technology in the next few years? Where do you see it evolving, or what's the biggest dream at the end of the road, sort of say? Not the end of the road, but on the horizon.
Yeah, so in the next few years, I really see the robotics market as the place to be for us. Yeah, you really see this big advancements in humanoid robotics. And yeah, with the advantages that I showed with shortages on the labor market, for example, but also these dangerous environments, I think there can be huge benefits there of humanoid robots, and of AI leaving just a virtual space and being able to have an effect in the real physical world. But yeah, for those robots to be able to have an impact and to be useful, they need to learn first. And I think that's where there's a very interesting challenge for us as a haptic device company.
Exactly. I was just about to ask about this, and I agree with you. I think that's one of the main challenges laying ahead of us now. So hopefully this can evolve together in a healthy way, so to say.
Yeah.
That's great.
Yeah, and also indeed to keep it human, and that's where
Yes,
touch and the sense of touch is so important.
exactly. Super important. Relating to that, I'm very curious to try this because you explain it very well, and I can sort of imagine what it feels like and how it interacts when you're in VR. But I think the best way to really experience it is, of course, to put it on and experience it. And a question related to that is very practical. Is there any, I don't know, fairs or events that you are present this year that maybe people can visit and try this out for themselves? Or how does it work? Do you provide demos or something?
Yeah, we will be at Laval in
Right.
early April. That's one I know for sure from the top of my head.
Yeah.
Maybe Natalia can maybe in the chat, Natalia, if you
I think it's
know.
Laval Virtual, right? 9
Yeah,
to 11 April. Yes, I have the link here. Let me share it. This one.
But you're completely right. It's we make a product that you really have to experience, because it's about how it feels. So we go
Right.
to quite a lot of events to give demos. You can always have a look at our website or our socials to see where we will be. And if you're interested, you're in a neighborhood, get in touch and you can come by our office for a demo as well. We are currently based in Rotterdam. We moved from Delft to Rotterdam at the end of last year. Yeah, very welcome to come experience our
Maybe we
gloves.
should organize an excursion, Belgium to the Netherlands, and
Yeah,
see for ourselves. Would be super cool.
indeed.
Let's see. We have one more question from Serkan. How would generative AI impact or enhance your product and user adoption? If you can tell something about that.
How would it? Well, I think it would have. How it would impact our product directly, I don't think there's a huge impact in the hardware design as of yet. But of course, generative AI in the generation of the simulations itself, that's not my expertise, but I think that a lot can and will happen there. I think you also had a Tech Espresso about
Yes.
the subject, right?
Yeah. How to use generative AI tools to build virtual worlds, really, because that's, they're strongly linked together and more applied together as well. So I'm sure in the future that the haptics will get involved as well.
Yeah.
Probably a couple of years from now, but yeah, interesting to think about. Let's see. Natalia also shared that they will also be at ICRA in May. Maybe do you have a link for that, perhaps? We can share. All right, the International Conference for Robotics. I have it here.
Yeah.
Awesome.
And then we plan to have a demonstration with the Rembrandt prototype as well. In Laval, we will be with our Nova 2 gloves.
Nice. Okay, great. Thank you so much. Thank you for sharing the information also there, Natalia. She dropped her link to get in touch also with the SenseGlove to maybe get an appointment or a meet up there. That's awesome. Let's see. I don't think there's any other questions coming in for the moment, so I think we can round up here. Someone is typing, so I'll wait for that for a little bit. If you have questions beyond this webinar, feel free to contact us through XR Valley channel, so we can be in touch again with SenseGlove and forward them. So yeah, thank you so much, Anna, for joining us today and sharing your amazing products. It was really, really cool. And thank you also for, I think it was amazing. You did a really good job in explaining how it feels and how it works. I could really imagine it. So I can imagine that's a challenge. So
good to hear that it came across.
Yes.
It can be hard indeed to
exactly.
Just in words describe how something feels.
Exactly.
But thanks again for having us, and thank you for the audience questions as well, you guys, for your attention.
Exactly. And I would say, Anna, please keep us up to date on future developments as well. We might be going to Laval as well, so maybe we can meet. Let's see. That should be very cool.
Yeah.
Awesome. Some final practical announcements regarding this webinar. As I said, if you still have questions or you want to get in touch with SenseGlove after this, please reach out to us or to them directly. You will receive links to their website and socials as well in a follow-up email. Good to know also the recording of this webinar will be available on our YouTube channel next week. You will receive a link to that also in an email after this webinar. And last but not least, the next Tech Espresso will be on April 24th. Initially, it was April 27th, but as it is a holiday in Belgium, I've moved it 1 week later. So hopefully as many people can join as possible. And you will also receive an invite for that in your email automatically. Thank you so much for joining today. We hope that you learned something and hope to see you in the next edition. Have a great night and see you soon.
Bye-bye.
Bye-bye. Thank you.